we will start talking about Python. I have a very easy as well as difficult task today. Difficult because I'm supposed to give a broad overview of Python, at least try to get you interested enough in the rest of the workshop. It's also easy because all the technically difficult stuff, like exactly what the things I'm going to talk about today mean, that's going to be tackled primarily tomorrow and the day after, and in the next few days. And most of that difficult job is going to be handled by the other two speakers. So, of course, I still hope that you should be able to at least get a flavor of what we can do with Python and some idea about very basic Python programming from this talk. And I must apologize that some of the things I'm going to talk about may seem to be too trivial and absolutely simple to most of you. But there is a wide spectrum of audience right now. So I'm essentially assuming that the audience has had no exposure to Python before, which of course I know is not true for most of you. So if you find it a bit boring, I apologize for that, but let me start anyway. So now, I hope you can see my PDF file right now. It's called Using Python to Teach and Play. Can you see that? I'm getting no response. So somebody can you please type out and say that? Or
Yes, we can see.
Yes, we can see.
okay, fine.
You can.
Okay, fine. Then, yeah, unfortunately, I don't. I am using a system which is completely unfamiliar to me because my own computer crashed on me, so I'm borrowing a computer without the owner's consent right now, and I'm using Windows, which I simply never use. So, okay, let's start anyway. Enough for the excuses. So, I'm going to essentially discuss what Python is, and most of you know that already. So Python is a language which was created by somebody called Guido von Rossum in 1992. So it's a relatively new language. The oldest language which is still in use today perhaps is Fortran. C is a close second. So they are both granddaddies in the programming language world. Python is actually quite a new entrant, although by now it's 28 years old. So it's sort of in its youth, so to speak. Now, you might think Python, the language, is not named after the snake, despite the fact that Python's logo actually has a stylized snake in it. The language is actually named after a very famous comedy team called Monty Python. And if you have not seen Monty Python's work, I definitely suggest that you please take your time and and you can find many of the wonderful works in YouTube or other sources, and you should definitely try to take a look at them. Guido von Rossum was a great fan of Monty Python, and that's why he named his language Python. In fact, if you read the documentation properly, and if you know a bit of the Monty Python folklore, you should be able to see in the documentation some signs of the jokes that this particular comedy team has made. So it's actually pretty funny. If you even the formal documentation for Python is actually pretty funny if you really are aware of the jokes. Okay, so why should we talk about Python? Now, this is a slide. This and the next slide is what I used to prepare when I first started teaching Python, which was around 15 to 16 years ago. 16, I guess. And at that time, we had to sort of justify why anybody would at all talk about Python. So, why Python? The pros is Python was created as a language for teaching computer science to be precise. And as a result, it was deliberately kept as simple as possible, so that the basic concepts that the teacher was trying to get across, they did not get obfuscated by language details. So What Guido von Rossum deliberately did, and what other developers who followed him kept on doing, is that they tried very hard that the concepts do not get obfuscated by details of the language. So most of the things which you have to do in other languages, but are sort of things that you have to do anyway, you don't really need to do in Python, because Python assumes that you're going to do it anyway and does it for you behind the scenes. So as a result, it's very, very simple to learn. It has a very clean syntax, as I hope I will make clear to those of you who do not know this before. It has a uniform style. I will also emphasize what this means when I go to programming examples. And there's another thing, it's an interpreted language, which sometimes is used as a sort of demerit or a shortcoming of the language. But actually, the very fact that you have an interpreter makes it possible for a user to learn it much more quickly. And I will try to illustrate that. So I'm going to talk about what an interpreter is soon, but right now, let me just go on. And basically, because it is a rather new language, comparatively that is, it had the advantage that it could be designed to take the nice features of many, many languages which came before it. So if you are familiar with other programming languages, sometimes you might feel, aha, Python does the same thing. That's because Python perhaps almost deliberately took certain features of different languages, which were the best possible features, at least according to the developers. And over a period of 28 years now, it has evolved into a very, very large and powerful language. Large in the sense it has a lot of various modules and features and so on. It has been extended by a very large number of modules, which are essentially, okay, we're going to talk about modules in detail soon. But some of the modules that we are going to meet in this workshop are things like NumPy, SciPy, Matplotlib, then there will be pandas, and we will also take a look at some of the modules for machine learning near the end. And what you can also do with this language is that you can actually carry out all the different standard formalisms of programming. We are usually, most of us, at least the people who don't do programming professionally, most of us actually do something called procedural programming. But there are other methods of programming like object-oriented, which is of course very, very important nowadays, and we will discuss that a bit in the workshop. And there's another one which is very, very important for say artificial intelligence people and other branches as well. It's called functional programming. And all these different modes of programming are actually carried out very well using this method. So the language actually supports all of them. And what used to be of great importance once is that a lot of old software, people had programs written in Fortran, in Python, or other languages. And all of those could be reused. You didn't have to recode them. You could reuse them by wrapping them inside Python code so that they sort of look like Python. Okay, so these are the advantages. At least these were some of the advantages which I used to list when I used to give this talk, say 15, 16 years ago. What about the disadvantages? Sorry. Well, let me point out, and this is being emphasized here, this is a very, very old slide. So the disadvantages that I'm going to talk about here are really disadvantages which were there long time ago. So 15 years ago, we had to sort of convince people as to why we should talk about Python at all. We would say, people would start by saying it's less popular. Then we would counter that by saying, well, Google uses it, so it can't be less popular. NASA uses it for a huge amount of their computation. This is then. And the Linux operating system, which sort of is taking over the world nowadays, its installer is written in Python. As a result, every Linux installation has to come with Python wrapped in it. There are many scientific applications and so on. And I'm really not going to talk much about this because, frankly, this is a very incomplete list. And as I say, this is the old slide. One thing, the advantage that I talked about, Python is interpreted so you can learn it easily. Also comes with a disadvantage that is makes the program slightly slower. Around 80% the speed of C was the case again 15 years ago. Today it's around 95%. It's still slower than C in most cases. But there are ways and means in which you can speed this up. And frankly, it's much faster to write a program in Python than in most of the other powerful languages. And it's a standard adage in computer industry nowadays that the programmer time is much more expensive than computer time. So computers have become so fast that this speed issue is really not important. The very fact that Python allows you to code complicated things much faster, that actually makes it has lessened its unpopularity, so to speak. So, except for very computation intensive applications, the fact that you can develop programs a lot faster much more than compensates for the lack of speed. In fact, the lack of speed is not 80% now, it has become much better. And well, this was the old slide. And let me just talk about how popular it is today. Now, again, some of you may already, in fact, most of you already know this, but maybe it's still important to sort of wrap this around our heads. Well, machine learning, Python is almost unopposed. This is the language of choice. Almost no other language comes even close. Haskell is a niche language for artificial intelligence, but even the people who used to swear by it nowadays are switching to Python. Well, there are various different organizations which carry out this so-called rankings, and ranking is always a bad thing because you always rank based on certain features. Just like, well, the institutional rankings have just come out, so some of you are happy with that, some of you are very unhappy. But let me just tell you that most rankings are usually, well, just that. You should not really take them too seriously. Having said that, the 2017 ranking of Redmonk, which is a very popular organization for ranking programming languages, it was number 3 then. Then there's something called TOB index. It's a very old index which ranks various languages. At Python number 4 in the world. That was 2018. Then there's a huge list, so let's not really go through all of them. However, the 2018 codingdojo.com, for example, this particular organization actually checks how popular is a programming language among employers. So when you have a job requirement, which language is the most important? Java headed it at that time for the simple reason that Java was still a big thing in web programming. But number 2 was Python. And well, if we do a survey among the experts about people who are actually developers, Pact Publishing House carried out a survey and they found out that Python is the number 1 developing tool of choice for everybody. So let me just quickly tell you one thing. There's a consortium called IEEE, the Electrical Engineers Consortium, and they have a magazine called Spectrum, which takes a look at various all kinds of people who use programming languages, and they do a ranking. So in 2014 and 15, Python was at number 4. It was behind Java, C, and C++. In 2016, it was number 3. In 2017 summer rankings, well, let me just show you the ranking. This is a 2017 summer ranking. And you can see at the very top, Python is number 1 in 2017. C, Java, C++ comes in after that. Now, of course, as I said, these rankings are based on various different parameters depending on various uses. So the fact that it's number one may not be that important, but that is definitely one of the top three is actually something you can take away from this. And sorry, I made a mistake in the picture. This is 2019, which can just, this is the last one. I did this slide very quickly in the last 15 minutes, messed it up. But you can just see peeking behind the 2019 ranking is also Python goes first. Java comes next. C comes after that. C++ has dropped to fourth. 2020 is still yet to be out, but the indications are in 2020 also Python will be number one. So basically, the fact that Python is not a popular programming language among the experts, that's really not true. Even in scientific computation, it's becoming a big thing. And one of the major reasons why it's such a big thing is that it's completely being driven by machine learning. And the fact that Google has sort of thrown its weight entirely behind this. So some of you who are interested in this may have heard of things like TensorFlow and Keras. And these are things which are being used by which use Python extensively. So let me continue with the presentation. I hope, are there any questions at this stage? If there are any questions, you can unmute yourself and ask. But okay, so let's go ahead. Although the next thing that I'm going to show you is again not very technical, and it's really not.
Theory wants you to please revisit second slide.
Second slide.
Amit Theory.
Okay, second slide. Second slide meaning this one. This is my second slide. I'm not sure whether he wants to take a look at the picture of the Python again.
No.
Or the comedy show.
Amit, please repeat your question here explicitly. Or you unmute yourself and ask the question.
Yeah. So was there a question on the chat? I can't.
Amit, another question. There's another question by Ruma Maiti. Ruma Maiti asks, Python has two versions, 2 and 3. What is the difference between the two?
Of course, Python 3 is a later version, so it has some additional features. Unfortunately, some of the Python 2 versions, which I personally like, have been discontinued. So I am a bit ambiguous about whether Python 3 is better than Python 2. Okay, but Python 3, of course, has a lot more features. But for most practical purposes, the differences are very slight. We are going to illustrate some of them along the way as we go on. And I can see there's another chat, question which came in, which was how is Python better than Fortran and for scientific computation purposes only? Well, frankly, Fortran, that depends on what you mean by Fortran. Fortran 95 is a rather nice language. But unfortunately, most people who code in Fortran 95 have been trained in Fortran 77. So they code in Fortran 77, just use Fortran 95 language, which means that they do not use most of the advantages which the language offers. Having said that, if you want to do pure number crunching and only pure number crunching, then it is, frankly, Fortran may have just a slight edge, but frankly, that's really not that great. Right now, most of the really important Fortran numerical libraries, they have all been ported to Python, at least the newer ones, the more important ones. So I'm pretty sure you're going to see during the course of this workshop also things like how you can use NumPy and write code for very complicated calculations much faster. So one thing at least is true, that Python code will be smaller than Fortran or C code. And that, of course, will be much easier to write, much faster to write. And there's a question like, how is Python different from SPSS, AMOS, Stata, or R for statistical analysis? Well, let me point out that Python is a general purpose language. It has statistical modules which can use for statistical analysis. And frankly, statistics is not really my niche area. So, but from what I'm aware, Python can at least sort of do as well as R. And I personally find R syntax a lot more difficult to understand than Python's. But Python, after all, remember, is a programming language for general purpose. You can write general programs with R also, but that's much more difficult. So you have to clearly make a distinction between specific languages which are specific for certain purposes, like R, which is primarily geared towards statistics, or say software packages which sort of almost look like languages, like say MATLAB, which is primarily for mathematical matrix calculations. Python has the advantage that Python has statistical things. So now Junik Shengupta has a question which says, what makes Python so easy to modulate? AstroPy or ISO? I'm not very sure I understand the question. Do you mean, why is it easy to write modules in Python? I'm not very sure whether I understood this. Okay, and Ornobla has a technical question. Are they back compatible, Python 3 and Python 2? The answer is not completely. Some Python 2 code will not run in Python 3, but the changes are very slight. You have to make very small changes. And in fact, there are programs available which can change your Python 2 code into valid Python 3 code. That can be done. But frankly, the changes are very slight in most cases. And as we go on and illustrate the program throughout the workshop, I'm pretty sure you will see some examples of that. Junik Shengupta, I really didn't get the question. If you are asking why is it so easy to write modules, well, that's the way the programming language is. Well, Python was designed to be easy. In fact, it was designed so that you can directly translate your, what do you call it? Say pseudocode. Pseudocode is the way in which programmers often convey programming information to other people. It's not really programming language. It's halfway between English and programming language. And from personal experience, I can tell you this. If you have a pseudocode for a particular algorithm which you want to implement, Python can, if you are using Python, you can actually interpret that and implement that with almost zero effort. Python actually looks very much like pseudocode. Okay, so are the versions of Python available vary with Linux OS yeah, of course, because depends on which version they are packaged, but you can always install the latest versions. Between Fortran and Python, which is more faster, depends on what you want to do. There is no absolute answer to that. Some things are faster in Fortran. Many things are faster in Fortran, but many things are faster in Python. And it's much faster to write the program in Python. And as I said, you can actually use wrappers in Python. So you can identify places where your Python code is slow. And you can actually code that in C or even assembly language. And then it becomes very, very fast. That's an advantage which no other language will give you. In fact, if you have a very fast program written in Fortran, but it doesn't serve all your purpose, just a part of it, you can actually write Python code which will use that Fortran program as part of itself, talk to it, do calculations with it, and return back the value. Is it compatible with Windows 7? Frankly, I don't know. It has to be. There must be some version which is compatible. Maybe the latest version may not be. Frankly, yes. Windows is not something I have any clue about.
Let me answer this question. Yes, it is compatible with Windows 7, definitely. Yes.
No, maybe some later version may not be. I don't know.
Later version, I'm not sure, but Windows 7 we ran Python in Windows 7 many for
Yeah.
long.
Any questions about Windows and Python should be directed to the other experts here. I'm using a Windows
Yes,
machine.
I'll talk about. I'm Abhijit. I'll
Yeah,
talk
tomorrow.
about this tomorrow.
You're right. Tomorrow, Abhijit's talk will also have a lot of installation of Windows and compatibility issues and stuff like that in the beginning. Why is Python slower than C in certain cases? Because Python is an interpreted language. I will talk about what that is soon. Why that makes it slower. And one thing which makes C very fast is something called pointers, which frankly is banned in almost every modern language for the simple reason that it's extremely dangerous. So the advantage which C has of being able to directly manipulate memory locations is actually an advantage as far as speed is concerned. It also makes it very possible for you to completely screw up a system. And that is one reason why C is actually not the preferred language, especially where security issues are involved. So I'm not saying that Python is the best possible, although some people do say Python is the best possible. And but if you ask me privately, I would actually say that. But depending on what your particular application is, uh, for a very specific application, another language may very well be better. In fact, one of my very close friends who started out being a Python aficionado along with me has now sort of deserted and gone over to a new language called Julia, which I am yet to sort of appreciate fully. But Julia might very well become the language of the future and might become the best language to use, say, 5 years down the line. Right now, Python has the advantage that it sort of spans almost every sphere of human application. So you can use it everywhere. Well, that the last question about how Python is helpful in data analysis in experimental high energy physics. Well, there are lots of packages in Python which are already pre-written, which can actually handle various data analysis works. And also, right now, experimental high energy physics, for example, uses machine learning in a big way, simply because things with LHC, the Large Hadron Collider, and providing so much data, much of experimentation has become big science, big data science. And big data, actually, you need a lot of crunching power, and it actually uses well, it provides you with lots of modules for that. And as you will see near the end of this course, hopefully, it's actually pretty easy to write machine learning programs in Python. So how much Python is important as a free open source software? That depends. That's a philosophical question, I hope. Well, if you ask people like me, we are a bit biased in the sense that any programming language, any operating system which is not open source, we consider that as personal enemies. So frankly, you should not really expect a very unbiased opinion from me. And that's rather ironical that I'm saying this while I'm actually giving a presentation from a Windows machine. But even the open source foundation is, well, it brings out some of the best things in humankind, if you really want to take a look at that. And Python is a very important part of that open source. Okay, so unfortunately, PFC 2020 could be Onaboda or somebody else. So Onaboda, right?
I'm Urnabu. I'm talking to Huimontidi. Huimontidi, would you please check whether your video is still on? If it is on, please put it off. Right? Okay, thank you.
Okay.
And also, please, Sanjay Chattopadhyay, please stop your video.
Yeah, video, of course, is very network intensive. It's sort of causing difficulty for other people. Okay, I think I will resume my presentation. There are many questions, I understand, but this is really not a one-off lecture, right? This is going to continue for a long time. I hope we hope to have a session in the last day where maybe some of these questions would already have been answered, and some of the new, you may end up with some new questions then. So let me just continue with what I wanted to show you. And before I start actually talking about Python, the language, or showing you the Python, the language in action, I can't resist this. This is something which, frankly, I've already talked about, but there's this very nice video which I found on Facebook. It's floating down on the net. It's sort of evolution of the programming languages as time goes by. And it's a long video because it starts a long way back, but let's just fast forward. You can take a look at this from the net anyway. Let's say around 91. So the best language was C at the time, C++, Fortran. Pascal, which is now nowhere, was still up there. And Python is nowhere in the scene. So this is showing you how much the various programming languages were used at those times. I have 2 more minutes, so please bear with me for this. If nothing else, the visual is quite nice. So basic just dropped off and Python entered at the bottom, if you can see that, 2001. 2002, Python moved over, it slowly starting to edge up, but still only 4% of people use it. It's growing in usage, as you can see. This is Python here. The top is being held almost constantly by Java, primarily because Java is a language which people use for web programming. So Python overtakes C# at that point, 2009. And then 2010, it sort of crosses both C, C++. PHP, of course, is an exclusively web programming language. So all the web browsers, etc., use that. That's why it's so far high up. And now Python is edging up steadily. And 2018, it just crosses every one of them. And this, of course, ends in 2019. But as I said, Python, JavaScript, Java, this is sort of the order now. Okay, so this is just a bit of an advertisement for the language that we are talking about. So I couldn't resist putting that down. Now, was Python initially developed to resolve the Y2K problem that emerged during 2000s? No, because it was developed 8 years before that. And the Y2K problem is really not that big an issue. It turned out to be a damn squib. And well, Y2K problem was not really because of the language. It was basically because people when people wrote code, they had no clue that somehow that using 2 digits for years could become an issue. So it became popular after 2001. That was more because the platforms, because the computers were becoming faster, so the speed no longer became an issue and so on. Okay, now what I want to do is present you with Python in action. That is, I'm going to show you some Python code and I'm going to give you a brief overview of the language. Of course, the language is too vast to really show you in one lecture, and that's what the rest of the conference is for. So as I said, I have this advantage that I can quickly go over many things, and which, of course, the other speakers will have to explain in detail to you in the next day. So this is more of an advertisement as to the kind of things you can do with Python, and geared primarily at people who have not used Python before, or So again, I apologize for people who might get bored with it. But let's just start and see what we can do with it. I'm using an interpreter called idle. And before I do that, let me just show you one thing. This is where we want to end the course, at least where I want to end the course. This is a program written in Python, which essentially does, which uses neural networks, deep neural networks, to do handwriting recognition. That is, it recognizes handwritten digits 0 to 9 and classifies them as to which one is 0, which one is 9, and so on. So near the very end of this workshop, we will have that. So right now, I don't expect most of you to understand the code. But let me point out one thing. This is a piece of code which will actually give you results which around more than 99% accuracy. Okay. But take a look at how big the code is. It looks very big, but note that all these things written in green are really documentation. So they're comments, they're not real codes. So as I scroll down, slowly, you should be able to see these things which are in other colors other than green. They are the actual codes. And by the time we end, I hope you should be able to understand every line of this code. So that's my aim, at least in this workshop. We will sort of show you how to understand this particular code near the end and write your own. But the important thing that I want to point out here is this has only around 60 to 70 lines of code, not more. Most of the other lines, this looks like a much larger program, but most of the other lines are basically just documentation, things which tell you what happens and so on, what this particular function does and stuff like that. And so any comparable program written in C, for example, would be, well, there's a sort of rough estimate that a C program with the same amount of work, which does the same amount of work, is at least 3 times longer than a typical Python program. So, as I said, it's much faster to write Python code because much of the work is sort of already done for you. I hope you will be able to appreciate that by the time we come to the end of the workshop. Okay? So, now, let me just start this idle, which is a Python interpreter. I'm not going to go into technical details as to which interpreter is better or not. In fact, I would have preferred using the Linux terminal. But as I said, I'm using somebody else's computer now. Without her consent, by the way. At least she doesn't know that I'm using it. I hope this is visible to all of you. That is, the font is okay. You can read what is there on the screen. I'm assuming the font can be seen by everybody. Okay. People are saying yes.
অপশনে গিয়ে আরেকটু ফন্টটা বড় করে দিতে পারো।
আরো বড় করব কি? আরো বড় করলে
আচ্ছা দেখা যায় যদি কেউ মোবাইলে দেখে একটু অসুবিধা হবে আর কি, মানে somebody is okay.
Can you make the screen full screen? Is it a full screen view we are getting? First of all,
mine is a full screen view. It's whether yours is a full screen view or not depends on what you are doing.
Oh, first of all, you did the right thing that you crossed.
Okay.
The
let me just inform people who are using this. You can actually change the layout of the screen. So near the edge, there's 3 dots. If you click on that, you can get a change layout. And in the change layout, you should, I think, change to Spotlight. Spotlight is what I'm using right now, which means I can almost the entire screen is what is being presented. If you use any of the other versions like sidebar or tiled, you will just see a very small. So if you're using something else, please go over to Spotlight. Okay, now I'm starting. Can the fonts be made a bit bigger? You're on mobile. Okay, let's see. I can make them bigger. I just have to find out how to make it bigger. The trouble is, as I said, I'm not very configure idle.
Configure idle.
Options.
Okay.
Go to options.
Yeah.
What did
And then
I
size
do?
you can see the size.
18.
Yeah.
18 may be too big, but let's see. Okay. Is this big enough now? Oh, you can use anything you want.
I think
Doesn't
okay.
matter.
I think okay. Now you can go on.
No, somebody asked, can I use Spider? If you're whatever you're comfortable with. But that on the mobile, can you find the spotlight option? I don't think you can. You can just turn your mobile into the around and it should work. I don't know whether there's a spotlight option on the mobile. Unfortunately, I've not used mobile often for Google Meet, so I don't really know. Can anybody else help out, please?
So I was using mobile for some time, but there is no option. I think mobile it is limited. So
No, but if presentation is going on, if you pin the presentation, I think you should be able to see the whole screen. Anyway, unfortunately, I'm not very sure I can help you with that. But let me just go ahead and try anyway. So this is the Python interpreter. And the Python interpreter, this means that it's ready and waiting for your commands. You give one command at a time. It immediately gives the answer. As I said, Python is an interpreted language. We will discuss the difference between interpreted and compiled languages in detail later. But let me just briefly tell you what the basic thing is here. Of course, as you all know, programming languages are written in what are called high-level languages, things which are almost like human language. So higher level a language is, the closer it becomes to language which ordinary human beings talk in. Of course, in our case, maybe English. So, so even if you have never seen a programming language before, you may not be, if you don't know the syntax of a particular programming language, a high-level programming language, it may be difficult for you to write your own program, but usually you should be able to make out roughly what the program does. And with Python, that's actually very, very true. Even though writing your own program would mean that you have to know the language a bit, reading a program, reading somebody else's program is pretty easy. Now, having said that, whether it's high level or comparatively lower level language or comparatively older languages, of course, it's a language which human beings can understand. The computer, as you all know, understands only zeros and ones, something called machine language. So some of you have had some experience in assembly language programming, I guess. So assembly language is basically machine language, where machine language code, instead of being written in zeros and ones, is written using mnemonics, using things which are easier for human beings to remember. But ultimately, machine language is what the machine understands. So between your human language and the machine's understanding, there has to be a layer. The layer is provided either by a compiler or an interpreter. They're basically both the same thing. They essentially translate human language, or higher level language, which we write programs in, into machine language, into zeros and ones. But there's a difference. Compilers compile your code and return a new file called an object file, which is made out of zeros and ones. So you have to compile the thing and then run it. So so basically, compilation is a two-step process. Compilation translates your higher level language into machine code, and then you have an object program, which is an executable, which you then run. Sometimes when you use some high level interface, these things may be integrated together, but ultimately it's a two-step process. Interpreters, on the other hand, take your command in, change it into machine language, and immediately executes that. So you don't have this intermediate level where things are saved. Now, this is a basic difference between the two. However, frankly, nowadays many interpreted languages are becoming more and more like compiled languages, and things are becoming sort of hybrid. But this is the basic difference. Now, what happens in an interpreted language is that you can give a command, and it gets executed then and there. And if you are using the Python interpreter, which I'm using right now I'm using a version of the interpreter called IDLE, which is the Integrated Development and Learning Environment. In IDLE, I can either have the interpreter running, the so-called console or the Python shell, or I can also run full-fledged programs. We will talk about full-fledged programs later. You have already seen one full-fledged program a while ago, the example program that I showed you a while ago. But right now, let's look at Python as an interpreter, and we are going to start with things which are very, very simple. So Python can be used as a calculator. So it can do things like 2 plus 3. Of course, not very difficult to understand. 2 by 3 is a division. This is where one of the major differences between Python 2 and Python 3 come about. In Python 2, the slash operator between two integers mean quotient. So if you do 2 by 3 in Python 2, you are going to get 0. Because when you are doing it between two integers, slash is supposed to mean how many times does the second argument go into the first argument. So 3 does not go into 2 at all, so you get 0. In Python 3, on the other hand, it means division. So depending on which version you're using, you have to be careful about this. Some people consider the fact that integer division gives you a quotient to be a sort of bad thing. But frankly, it is very useful. It's one of the things which I used to love about Python 2. And that has sort of been taken away by Python 3. But it can do something else. You can do things like 2 to the power n. You can do other things like 2 to the power 1000 or 10,000. Well, this is the problem with IDLE. It's not showing me the answer. It worked out the answer. You can see the cursor return immediately. But it's saying 63 lines, so I'm not going to show you this because it's going to fill up your entire screen. So 2 to the 10,000, of course, is a huge, huge number. It will take 63 lines of this thing. But you can see, with integers, Python can go as high as you want. But you can do other things as well. For example, can you do things like calculating the sign of a function, sign of a variable, the sign of 1, not a variable, constant right now. Well, apparently you can't. You try calculating sign of 1 and you end up with something called a name error. It's saying name sign is not defined. Now this looks a bit strange. After all, I'm claiming that Python is such a great language for doing computation, even scientific computation. And one of the simplest things, calculating the sign of an argument, it apparently can't do that. But this is where the concept of modules come in. In Python, some of the most basic things are available directly when you start. And if you want to see what are available when you start, there is a function for that. It's called dir. When you're writing a function, when you're calling a function, you have to give its name, followed by a bracket in which you give the arguments. Even if you have no arguments, you have to give the bracket to tell Python that you're calling it. So I'm calling the Python function dir. And what it does, it tells me these are the names Python knows right now. Annotations, built-ins, doc, loader, name, package, spec. These are all special names, as you can make out with the double underscores before and after. And it does not know anything else at this stage. Now that might seem like a bit of a problem, because if it does not know anything else, then how could it run the dir function at all? Because you can't see the dir function in here, right? In the list of names which Python knows right now. But that's because dir is actually inside this built-in set. So there are certain things which are there in built-ins which Python always has available. That's because everybody would need them no matter what kind of program they're writing. On the other hand, things like sine, cos, tan, or other things are really not that important for everybody. So what Python has done is package them in a module. So it's a module whose name is math. So if you want to call a function from the math module, the first thing you have to do is make the name math available to Python. So one way of doing that is import math. Well, I'm pretty sure most of you have done this before, and most of you may have done something else. But let's start with this. We do import math, and now let's take a look at the directory again. If you see, in the directory, all the names that people knew before are already there. Python already knew these names. In addition, Python knows this one new name now, math. And if you want to see what math contains, you can try help. And I'm pretty sure you have guessed that help is in built-ins. That's why I can call it without loading anything else. So help math. Okay, double click to expand. So this is, so it tells me what kind of functions are there in math. Say there's a function called acos inverse, cosine hyperbolic inverse, sine inverse, sine hyperbolic inverse, so on, ceiling, lots and lots of functions. The full list is not important. You can always take a look at this whenever you're using Python by running help. So all these mathematically useful functions are already available in the math module. And at the end, there are also some new data points available. E, exponential, the base of natural logarithms is already there. So is pi, so is tau. And there are special numbers called inf and none, which essentially are not a number and infinity. We're going to come to that later when we need that. But, okay, this yes is in answer to what? Oh, okay. So now that we have imported the math module, the name math is available to Python, and sine is in the math module. So it might seem that this should work now. Of course, all of you who have used Python before know that this will still not work. Okay, one question, this import math we have to use every time when we need this kind of function. Every time means every time when you are using code, right? But of course, in this one session, import math you have done once, the name math is known. In your program, you might have to include the name import math at the beginning. After that, you can use math all the time. But as you can see, just importing math will not help, because apparently import math still does not give you access to the name sign. And of course, as you saw, there is no name sign available. The only new name Python has learned right now, the only new name which is in what is called its namespace to be right now, is math. But what you want to do is from the math module, call the sign function. And this is the way in which you're supposed to do this. So math.sign1 will work. So you can make much more complicated things, like, so you can want to calculate square root of the exponential of say sign1. So you could combine all of these things together. You could say square root, so math.sqrt. And math.exponential. You might, of course, think that this is a pretty nasty thing to do, having to write math.sqrt every time. And there is a way around this. The way around this is simply, which most people who use math module use. But I will tell you one thing. at least when you are using more complicated modules, that is usually not a great idea. And that one is this. Suppose I want to use the sine function and sine function only. I can do. Now, once I've done that, so this syntax is different. That one was import math. This is from math import sine. Okay, there's a question. Argument of sine is in degrees or radians. The answer is has to be radians. There is no such thing as degrees. In scientific science, degrees don't exist. It's always radians. Although that's not really true. You will soon see that degrees are useful. Okay, sound is not clear. Is that a common complaint, or can others opine? Is the sound okay, or so it may be a problem at my end, it could be a problem at the other end. If sound is okay to most people, then I would ask you to check your network connection. Okay, most people are saying okay, so I'm assuming the problem is not at my end. Okay. Now, somebody asked, okay, in this, I lost track of the question that I was trying to answer. Argument of sine is in radians, of course. And okay, I think I've handled most questions till now. Okay, as I said, now let's take a look at what the directory of names tells us. Now note that in addition to the math, which was here, there's sine. Okay, somebody asked how to make math unknown. Of course, one way would be don't import math at all. The other would be to use another function, and you must have guessed it, it's a inbuilt function. To say do del math, and then they can look at the directory.
Shumdeep asked how to, sir, when we learn to download Python. Please answer this question.
I think Abhijit has already answered. Tomorrow there's a session which says installing. Downloading, I'm pretty sure he doesn't want to know the answer to that. He wants to know how to install. That's part of the detailed discussion tomorrow, at least for Windows. For Linux, frankly, you don't need to download Python most of the time. You need to download only some special modules. We'll talk about that. Okay, we can say Python is the best language, or all have equal importance in different specific fields. The answer is all have equal importance in different specific. Well, in certain specific fields, some languages are better. Remember, you should not expect a general purpose language to be able to compete equally well with a language which has been written exactly for one purpose. Installation in Linux operating system also, there is nothing to install, frankly. If you have a Linux operating system, Python should come with it. We will talk about how to install other accessories. And of course, there are some new systems which hide Python, but then can easily find out the scientific package which they usually give you. Frankly, discussing Linux operating system will be difficult because there are so many different versions. I can tell you what to do with Ubuntu. I will talk about that. Well, Abhijit's comment is Python is the first boy in the class. I'm not very sure whether I agree as an absolute statement, but there are certain cases, of course, in which it is much better than others, but there are others which work well. Yeah, I think I'm going to continue with what I'm talking about right now. If there are some very specific questions relating to my talk, please ask. Now, other questions we can, of course. There was no sound because I was not saying anything. I had to go away to disconnect my a call which was coming in. Unfortunately, my net is still down, so I'm using a mobile hotspot. So anybody calls me, the hotspot will get disconnected. So if you suddenly lose my connection, Obijita or Onavoda, please take over for the time being. Okay, let me continue with where I was. As you saw, now I have been able to delete the name math. So I don't have the name math accessible any longer. So if I tried, say, math.sign1, it's giving me an error because it says math.sign is, of course, from math, take the sign function. So there is no name math that it knows right now. But because I have taught it the name sign from the math module, I can actually now directly use sign. But what I cannot do is do something like exponential of sign. The name exponential is not known. And what I cannot do, as you may have already gathered, something like, as the name math is not known. So of course, what I can do is, if I know that the only functions I need from the math module are exponential and sign, for my program, I can say from math import exp, comma sign. That will work. And now this one will work fine. But as you must have guessed, this becomes a bit boring if you want to do extensive amount of mathematical calculation. So what people often do, and with the math module, this is sort of okay. With most complicated math modules, this is not what you really should do. When you say from math import star, it of course means that from the math module, you are importing everything that is there in the math module. So now, remember, even math module had things like pi, so you could calculate things like sine of 2 star pi. Of course, you're not getting 0, which you expect to get. What you're getting is a number which is very, very close to 0. And that's basically because whenever you do mathematical calculations using floating point numbers, you actually can incur some random errors because of floating point limitations. We are going to discuss this in detail later, but you should also realize that every time you use floating point numbers in calculations, there is a scope for some very tiny error. Of course, this one is a negligible error. This says 10 to the minus 16. Notice this e minus 16 means 10 to the minus 16. So it is minus 2.449 into 10 to the minus 16. Number close to what machine precision will allow you. Okay. So now I hope this concept of namespaces and importing names are available. In fact, if I now take a look at the directory, it will look much more imposing than before. With all these names which were there in the math module has now been imported into your namespace. And at this point, I'm going to steal an example which Onaboda actually uses often. So I like his example very much, and so I'm going to steal it from him. So what he says is, think of the namespace like your work table. So when you are saying, so they said a table where you have all your tools. So when you're saying import math, you're just taking the box labeled math, putting it into on your table. So every time you want to use something from the table, from that module, you have to go reach inside the box, bring it out. So you have to say something like math.sign. So going inside the math module, then taking the sign function out of it, then calling it. On the other hand, doing from math import star is like taking the box up, turning it over, and essentially dumping everything which the box had onto your table. So now everything inside the box is on your table, so you can use it. So I'm pretty sure Onaboda would love to use this analogy again later sometime, but I couldn't resist using this. Sorry for stealing this from you. But this is a really nice analogy to understand what namespaces and importing things mean. So these two modes of importing, import math means just bring the box math on the table. From math, import sign means just take sign out, put it on the table. From math, import star means just dump everything in the box on the table. So I hope that sort of makes the whole issue clear to all of you. And now what I'm going to do is I'm going to stop using complicated things like the math module and go over to something much more childish. So, well, I'm not sure whether all of you will appreciate this, but I'm going to use something which say is used at the level of class 5 or 6 or even lower to get people interested in the programming, into programming. And so it depends on how old you are, but many of you may remember that there used to be a programming language called Logo. So this was a language which people were exposed to in our generation, at least some of us, when we were really kids, and we could just draw pictures with it. Now Python has a Logo equivalent, and I'm going to use that to illustrate various properties of the programming language, various features of the language, and give you a quick overview of what you can do with various things, which are going to be treated in much more detail in the next 2 lectures. So I hope I'm still audible, right? I'm sometimes getting a no sound message, but that might be from earlier. Am I audible? Onaboda or anybody else, can you just unmute and tell me?
Yes, clearly audible.
Yes,
Okay,
you
okay.
are audible.
Because if I ask, I am audible, am I audible, and nobody answers, then it could very well be because I'm not. Nobody heard my question. Okay, now, as I said, there is a module in Python which now let me do one thing first. Let me get rid of all the clutter that I've dumped in. I've dumped in the entire contents of the math module into my namespace, and that might become a problem later on. So what I'm going to do is I could have deleted all these one by one, but that's way too difficult. It's much easier just to stop the interpreter and start all over again.